Okay, we're looking at problem number 1. The average time a subscriber spends reading the Wall Street Journal is 49 minutes. Assume the standard deviation is 16 minutes and the distribution is normal. Part A says, what is the probability a subscriber will spend at most 1 hour reading the journal? Well, we know the distribution is normal, so I'm going to use the normal probability density function. Centered at 49 as the average, and standard deviation is 16. And I'm looking for the probability that they spend at most 1 hour or at most 60 minutes. So I want to find the probability that the random variable x, the amount of time a subscriber spends reading the journal, is somewhere in this interval. Now, density functions are set up so that to calculate the probability of being in the interval, it's the area under the curve above the interval. So I need to find the area under the curve here. The probability that x is less than or equal to 60 is the area under the curve of the density function above the interval. Now, to get that area, I'm using a table. And to use the table works by using a z-score. So I'm going to take the z-score of 60, and that turns out to be 0.6875, or approximately 0.69. So the probability that x is less than or equal to 60 will be a probability that the z-score from the table is less than or equal to 0.69. So to find that, I'm going to look up the z-score of 0.69. It's in the positive value table. 0.69, 0.6 is the row, 0.09 is the column, and I get that the area from that z-value, and the z-value here is 0.69, that goes with the 60, the area under the curve down from that is 0.7549. And that's exactly what I want. So 0.7549, or 75.5%, spend 60 minutes or less time reading the journal. Okay, let's go on to part B and see how that one works. Part B says, what is the probability a subscriber will spend more than 30 minutes? So again, we're talking about the same problem, talking about a normal distributed problem with average 49 and standard deviation 16. And we're asked the probability that the random variable, or the time a subscriber spends, what's the probability that it is more than 30 minutes? In this case, 30 is below the 49, and the interval that we're talking about is from 30 up. Again, the probability of being in that interval is the area under the density function above the interval. And to calculate that area, I'm going to have to calculate the z-score of 30. So 30 subtract 49 divided by 16 gives me a negative 1.19. So 30 has a z-score of negative 1.19. But when I look that value up in the table, I'm going to go to the negatives and look up a negative 1.19. That's row negative 1.1 over to column 0.09. The table gives me a value for the area looking down. The table always works that way. It takes the z-score and looks down from that. So 0.117. That's not the area that I want. That's not the probability that I'm looking for. So what's the probability that x is greater than 30? It's the probability that z is greater than a negative 1.19, which is, since the area under the entire curve is 1, it's the blue shaded area that I want. That's going to be the answer. I'm going to have to take the 0.117 away from 1, and I get 0.883, or 88.3% spend 30, or I spend more than 30 minutes reading the journal. 88.3% spend more than 30 minutes reading the journal. Okay, part C. Now this one is different still, because it's still with the same problem, so I'm going to go ahead and create my normal distribution. This is my density function. Standard deviation is 16. But this one says for 10% who spend the most time reading the journal, how much time do they spend? So they're saying that 10% spend more than what amount of time? Notice that they're actually giving me a probability, and they're wanting me to find the interval. So I need to find this x value. The x will answer my question. Anybody who spends more than x time reading the journal is in the upper 10% of subscribers. Now, the only formula I have to relate all these values is z-score. If I had the z-score for x, I could maybe solve for x. To get the z-score for x, I'm going to look backwards in the table. Realizing that the table always looks down, I'm going to find the area under the curve, which actually, this area is just going to be 0.9. I just take 1, subtract the 10%, I'll get 0.9. I'm going to go into the table, and this would be the positive table. I'm going into the table and get as close to 0.9. Now, I'm not looking in the rows and columns. Those are z-scores. I'm looking in the body of the table and trying to get as close to 0.9 as I can. And that value is 0.8997. And that comes in row 1.2 and column 0.08. So my z-score for x will have to be 1.28. That 1.28 z-score matches with the 90% area looking down. Now, that will give me a way of solving for x. The z-score for x is 1.28. And whatever x is, subtract 49 divided by 16. That will have to be 1.28. Now all I have to do is solve for this equation. I'm going to multiply both sides by 16, and I'm going to add 49, and I get x is equal to 69.5 approximately. So my answer is the upper 10% of subscribers spend 69.5 minutes or more reading the journal. Now, this problem demonstrates pretty much two types of problems in section 6.2. One problem is calculating a probability when you're given an interval. That's part A and part B. And sometimes you have to work with the fact that the area under the curve is 1, and the table doesn't always directly give you the probability. Sometimes you have to subtract from 1, and we'll see another example of another situation what you'll face with that. But the other type of problem is given a probability, as with part C, where we've given the 10%, what is the interval? So that's kind of the reverse type problem. So the two problems are given an interval, find the probability, and like in part C, it's given the probability, find an interval. It all really focuses in on the z-score formula. That's the relationship between average and standard deviation and your endpoint value and z-score. And the table helps us get these areas. The area under the density function above the interval is the probability. The table helps us to match that probability with a z-score and vice versa. It helps us answer our questions. I hope this helps, and I have another example, number 2, that you'll want to see.